Welcome back to Pi Academy. This is 7th video on real analysis based on sequence of real number and others videos link provided in the description box. In this video, I will discuss from question 31 to question number 35. Now question number 31. Let sequence an, bn and cn be sequence of real numbers such that bn equal to a suffix to n and cn equal to a to n plus 1. Then sequence n is convergent. This implies sequence bn is convergent but cn need not be convergent. Implies cn is convergent but sequence bn need not be convergent. Implies both bn and cn are convergent. And if both bn and cn is convergent, we know that since sequence n is convergent and bn equal to a of a suffix to n and cn equal to a suffix to n plus 1, that is a to n, bn and cn are the subsequence of n. Since the sequence n is convergent, therefore the subsequence are also convergent. Therefore our option C is true. This implies both bn and cn are convergent. Now question number 32. Let sequence an and bn be sequence of real numbers defined as a1 equal to 1 and for n greater equal to 1, n plus 1 equal to n plus minus 1 whole to the power n into 2 to the power minus 1 and bn equal to 2 into a suffix n plus 1 minus n divided by n. Then sequence n converges to 0 and bn is Cauchy sequence. Sequence n converges to a non-zero number and bn is a Cauchy sequence. Sequence n converges to 0 and sequence bn is not a convergent sequence. JAM MSc 2008. Now solution. Here a1 equal to 1 and a2 equal to 1 minus half. Since n plus 1, given that n plus 1 equal to n plus minus 1 whole to the power n into 2 to the power minus n. If we put n equal to 1, then we get a2 equal to 1 minus half. Similarly a3, if we put n equal to 2, then we get a3 equal to this. Similarly a3, a4, a5 and so on. Thus n equal to, here clearly this is 1, here n equal to, n will be 1 minus half plus 1 by 2 square minus 1 by 2 cube plus so on. Then this is a GP series with common ratio minus half. Then the sum of the GP series n equal to a into, here a equal to 1 into 1 minus r to the power n by 1 minus r, here r equal to minus half. Then this equal to, here this equal to 1 minus 1 minus 1 whole to the power n divided by 2 to the power n by 1 plus half, that is 3 by 2. Then if we taking limit as n tends to infinity, then this is 0 and 1 by 3 by 2, that is 2 by 3. And now limit bn, given that bn equal to 2 into a suffix n plus 1 minus n divided by n. Here bn, the limit bn equal to limit of this and limit of n plus 1 is 2 by 3. This is also 2 by 3 and n equal to 2 by 3. Now we calculating this, we get 1. Therefore the limit n is 2 by 3. The sequence n converges to non-zero number, since 2 by 3 the sequence n converges to 2 by 3 non-zero number, and the sequence bn is also a convergent sequence of real numbers. Or bn, since bn is convergent sequence of real numbers, therefore it is Cauchy sequence. Hence our option B is true. The sequence converges to a non-zero number and sequence bn is a Cauchy sequence. Now question number 33. Let m equal to half 0 1 4 1 and x equal to 3 4. Then limit n tends to infinity m to the power n into x. This equal to does not exist. is 1 2, matrix 1 2, is matrix 2 4, is 3 4. Clearly mx, m square x, m cube x and so on is a sequence of matrix and this is convergent. Now mx equal to, here the value of m is this and the value of x is this. Now we get mx equal to m into x, then calculating this we get 5 by 2 or 5 and 4. Similarly m square x we get, calculating this we get 9 by 4 4, and m cube x we get 17 by 8 and 4. Therefore, and clearly this is 5 by 2 and 4 4 4 4, it is common element, but here it is changed, that 5 by 2, 9 by 4, 17 by 8. Therefore 5 by 2 we can write 5 by 2 as 2 plus 1 by 2, this also 2 plus 1 by 4, 2 plus 1 by 8, and similarly we can write m to the power nx equal to 2 plus, and this is 8 equal to 2 cube, this is 2 square, 2 to the power 1, thus when 1 2 to the power n and 4, m to the power nx, we get this. Here if we put n tends to infinity, then we get 2 and 4, 2 and 4, a11 is 2 and a21 is 4. Therefore limit n tends to infinity, m to the power nx equal to 2 4. This hence our option. Now question number 34. Let 0 less than a1 less than b1 for n greater equal to 1 define as an plus 1 equal to root over n bn and bn plus 1 equal to an plus bn divided by 2. Then which one of the following is not true? Both an and bn converges, but the limits are not equal. Both a and bn converge and the limit are equal. bn is decreasing sequence and n is increasing sequence. Solution. Here 0 less than a1 less than b1 and n greater equal to 1. Applying m greater equal to gm, we get a1 plus b1 divided by 2 greater equal to root over a1 b1, and this equal to b2 by the given condition, and this equal to a2 by the given condition. Therefore similarly b3 greater equal to a3, p4 greater equal to a4, and we get bn plus 1 greater equal to n plus 1 for all n belongs to capital N. Now n plus 1 equal to root over n bn, this is given, and this clearly this greater equal to n for all n greater equal to 1. Therefore sequence n is increasing sequence, is monotonic increasing sequence, and also a1 lesser equal to n lesser equal to bn lesser equal to b1 for all small n belongs to n. Therefore the sequence bn is monotonic decreasing sequence, hence our option sequence n is increasing sequence, it is true. Sequence bn is decreasing sequence, it is also true. Since therefore sequence n and bn are monotone and bounded, then convergent. Therefore sequence n and bn convergent. Let limit of n equal to l and limit bn equal to m. Now by the given condition limit n tends to infinity n plus 1 equal to limit n tends to infinity root over n into bn. Here the limit equal to l and root over l into m. This equal to l square equal to lm or l equal to m. Therefore sequence n and bn both are converge and the limit are equal. Hence our option B, both n and bn converge and the limit are equal. It is also true, but we have to find which of the following is not true. Hence the option A, that is n and bn converge but the limit are not equal, this is true. JAM MA 2017. Now question number 35. Which one of the following is true? JAM MA 2017. Every sequence that has a convergent subsequence is a Cauchy sequence. It is not true. We know that if a sequence is convergent, then it is Cauchy sequence, and if a sequence is Cauchy sequence, then it is convergent. but it is given that if every sequence that has a convergence subsequence, it is a Cauchy sequence, hence it is not true. Now option B, every sequence that has a convergence subsequence is a bounded sequence. It is also not true, because if a convergence sequence is bounded, but if the sequence has a convergence subsequence, that it may or may not be bounded sequence. Therefore option B is also not true. Now option C, the sequence sin n has a convergence subsequence. The sequence sin n is an infinite, this is an infinite bounded sequence of real number, infinite and bounded. Therefore we know that by Bolzano-Weierstrass theorem, the sequence has convergence subsequence by Bolzano-Weierstrass theorem. Hence the option C is true. Now option D, the sequence n cos 1 by n has a convergence subsequence. No, it is not true, because this is not bounded. Hence the sequence has no convergence subsequence. Hence our option C is true. And that's all. Thank you for watching. Please like, share and subscribe, and hit the bell icon to get all the notification of my new videos.